Hi everyone. In today's video, I will be going over the test review for the sum, difference, half, and double angles test, 5-2 test. Reminder, this is all that you get for the test. So you get all of the formulas, the sum and difference formulas, the double angle formulas, the half angle formulas, and then on top of that, you do get a small copy of the unit circle. Additionally, you have your calculator that you're able to use on the test. With all of those materials, really you just need to know how to evaluate the formulas. That's pretty much it. And then how to do the algebra parts, of course. So on the front page, I'm going to very quickly go through the answers to these. I'll comment on certain problems as I go. Otherwise, it's pretty straightforward. So, number 1, 2 sine of 45, cosine of 45. That is the sine of 2u, that's the double angle formula, where u is 45. So it's 2 times 45, so your final answer is sine of 90 degrees. Notice in the directions it says it needs to be in terms of a function of one angle. So if you don't write it as a singular number, if you write it as 2 times 45, you will lose a point. All right. Number 2, this is a cosine formula. This is the half angle formula, so u over 2. U is 23. Half of 23 is 11.5 degrees. Number 3, this is an old formula. This is from the Pythagorean identity. Sine squared plus cosine squared equals 1. It doesn't matter what the angle is. Number 4, this is another one. Secant squared x minus 1 is equal to tangent squared, and then this one you do fill in whatever the angle value is. Number 5, another old one, this is the cosecant squared formula, and you fill in whatever the angle value is. Number 6, this one is a tad tricky. This is using the tangent of 2u formula. And this time u is not just a number, it has a variable in it. So it's tangent of 2 times 4 theta, and then doing the math there, that gives us tangent of 8 theta. And then technically theta can be in degrees or radians, so we leave the symbol off. 7, this is a cosine formula. This is one of the cosine 2u variations. Remember, cosine has 3 different versions of the formula. When you choose which one to use, I recommend using the top one. So, and u is 14, so that will be cosine of 28 degrees. Number 8, this is a half angle formula. This is the sine formula. And half of 36 is 18 degrees. Number 9, this is another half angle formula. This is one of the tangent ones. Again, tangent has 2 options, and this one is the top one. So, this is tangent, and then half of 29 is 14.5 degrees. Number 10, 1 minus sine squared 35. This is another one of the cosine 2u variations. So this is cosine of 2 times 35, that's 70 degrees. Number 11, this is a tangent sum formula. So you have u and v, that's 40 and 20. Add them, you get 60. Number 12, 2 sine of 43, cosine of 43. This is the sine 2u formula. 2 times 43 is 86. Number 13, cosine 80, cosine 20. This is a cosine formula. This is the difference formula because it's got that plus in the middle. It's trying to trick you. Yeah, this is the difference formula. 80 minus 20 is 60. 14 cosine squared minus sine squared. This is a cosine 2u variation. It's the first one. So this is cosine of 2 times 82. That's going to be 164 degrees. Number 15, sine cosine. This is a difference formula for sine, where you do u minus v. And in this case, we have fractions with different denominators. So we have 5 pi over 4 minus, we're going to change this to 2 pi over 4. So we get 3 pi over 4 for our answer. Number 16, we have another one of those. This is a cosine formula, and it's the opposite of what it says in the middle for the cosine. So this is the sum formula. These have the same denominator, so these will be easy to add quickly. 9 pi over 11. Last problem, number 17. Here's another sum formula for sine. You just add the 50 and the 35, so that's 85 degrees. All right, that is it for the front side of the study guide. These kinds of problems will appear on the test. As you can see, they should be pretty easy for you. So hopefully you're able to get these down so you can earn some very easy and quick points on this test. Going to the next page. I'm going to go through all of this. So this will take a moment for sure. So on all of these, they give us sine, cosine, or tangent, and then we have to find the other two functions. And then they tell us which quadrant each of these are in. We need that information as well to determine if sine, cosine, and tangent are positive or negative. So for our first one, we read this as A is in between 180 and 270. And if you need the visual, between 180 and 270, that is quadrant 3. Between 270 and 360, that is quadrant 4. Between 90 and 180, that is quadrant 2. From here, we need to figure out the values of cosine of A and tangent of A. And we can kind of deduce these somewhat already. We know that sine is O over H. We know that cosine is A over H. And we know tangent is O over A. So we can at least fill in a little bit. So tangent is 3. The O goes in here. And then the 5 goes in here for the H. And then since we're in quadrant 3, we remember the acronym. All students take calculus. So quadrant 3, tangent is positive, and then cosine is going to be negative along with the sine value. So that kind of helps also while we're thinking about these things later. All right, let's figure out what our A value is. That's the only thing we're missing. So we are in quadrant 3. And that's going to be down here. So I'm going to kind of zoom in, if you will, on it. And then we draw our triangle. So this has to come out from the origin. And then our angle, we called this alpha a couple units ago. So we have our vertical, our horizontal, and then we have our angle here. So we know that the O is 3, and O opposite the angle. And since this is the bottom of the y-axis, the negatives, this is a -3 in the triangle. And then our H is 5. And then we use Pythagorean theorem to find the missing side. Now this we call a Pythagorean triple because our answer here will be a whole number, because I already know what it is. So this is one hopefully you will memorize. But if not, you can always use Pythagorean theorem. I will show that on a separate post-it note. So we're missing the a here. Okay. So we have -3, and we don't have to include the sign, but we are going to square it, so it doesn't matter. Squared plus a squared equals 5 squared. 3 squared is 9. 5 squared is 25. Subtract by 9, we have 16. And then we square root both sides. A is equal to 4. And then since we're on the left side of the x-axis, that's where the negatives are, that's a -4. So, a value is 4. So this is now -4/5. And then, now I've already thought about the signs here, so I know tangent's not negative, so that might have thrown you for a loop. This would be -3 over -4 if we're getting technical here, because our O is the 3. But since they're both negative, this is going to turn to be positive. So that still came out correctly. So that is kind of the benefit of thinking about the signs beforehand. You're less likely to mess that up later. Okay, so there are the A's, the trig functions for A. Now let's repeat that for B and C. I'll try to go a bit quicker this time. So we have cosine of B, so I need sine of B and tangent of B. So this is A over H, and then this is O over H and O over A. So we know H is 13 there, and then we know A is 12 here. This is in the fourth quadrant where cosine is positive. So we know sine and tangent should both get negative. We know that much so far. Now we can use the plane to figure out our missing side and all that. So quadrant 4, again, I'll kind of zoom in on that when I draw it. Focus in on that. So we draw a diagonal out from the origin, and then we make our vertical connect to the x-axis. So then the angle goes up to the x-axis. All right. We know that A, that is always on the x-axis, is 12. And we know H is 13. So then this is on the positive side. H is always positive, so this has to be a negative. And then again, we can use Pythagorean theorem to figure out the missing side. This will be another Pythagorean triple, of course. So we have 12 squared plus, we're missing O, so O squared. I might do like that just so it's fancy. Can I recognize it later? And know that it's not a 0 mainly. And then 13 squared. Remember, the hypotenuse H always goes in the C spot, because this is like A squared, B squared, C squared. Surely you knew that. From here, 12 squared is 144. Plus O squared equals 13 squared is 169. Subtract 144. O squared is equal to 25. And then square root both sides. O is equal to 5. So then, filling this in, this is a 5, and we've already acknowledged it's negative because it's on the bottom side of the y-axis. It's under the x-axis where the negatives are. Okay, so we just need to fill that in. So I've already got the negative there, so we don't have to worry about that. And those are my 3 values. Last one. We have tangent of C equals -8 over 15. So we need sine and cosine. That's O over H. And then A over H. We already know tangent, that's O over A. So we know this is an 8, and this is a 15. And then we're in quadrant 2. Quadrant 2 is where the sine is positive. So that means cosine is going to be negative here. So it was the 15 that had the negative technically. And then we just need to find H. Again, this will be another Pythagorean triple. Really, the only reason to do all the work in the unit circle with the plane is to help deduce the signs. Since I've already thought about it, technically we could just do Pythagorean theorem and not fully draw the triangle in the coordinate plane, but I'm still going to for good practice. Okay, we're in quadrant 2, so I'm going to zoom in on that when I draw this. Draw your diagonal out from the origin. Vertical connects to the x-axis. It's where our right angle is. And then our alpha angle also connects to the x-axis there. Okay, we know that O, which is always the vertical, opposite the alpha, is 8, and it's positive. We're going up from the x-axis. And then we know A, that's going to be the other side. That's negative 15, because we're on the negative side of the x-axis. Pythagorean theorem to find our missing side. I actually do have the space, so I'm going to go ahead and do this on the paper. So we have 8 squared plus negative 15. Again, it doesn't matter if you put the sign in there, just make sure that you square it properly so you get rid of the negative. Equals, this time we're missing h, so h squared. 8 squared is 64, plus 15 squared is 225. 64 and 225, 289. And then we square root both sides. If my memory serves me correctly, that is supposed to be 17. Square root of 289 is 17. Yes. So h is 17. So now I know the bottom of these, it is 17. All right, so we have all of our trig functions for every single letter. Now we can evaluate 18 through 26. So we're finding the exact value, and they're basically telling us which formula to use. So a plus c, that's the sine formula for the sum. And then, of course, instead of u and v, we're going to plug in a and c. So we have sine of A, cosine of C, plus cosine of A, sine of C. And for those of you keeping track, that's going to be a point, is just filling in, writing down the formula, plugging in the letter correctly. From here, this is the very important point, is setting up the problem. So sine of A is negative 3/5. This is your reminder to fully replace the function and the angle. Don't just put this in and put sine of this. Don't put this inside of A. This is not what A is equal to. We don't know what A is, but we know sine of A is negative 3/5. Cosine of C is negative 15 over 17, plus cosine of A is negative 4/5. Sine of C is 8 over 17. From here, it's just multiplying fractions and then adding. So, negative 3 times negative 15, that's positive 45. 5 times 17 is 85. Plus, negative 4 times 8 is negative 32. 5 times 17, that's still 85. And then we're just going to add our fractions. 45 minus 32, that is 13 over 85. Done. Number 19, cosine of B minus C. This is the difference formula for cosine. Trying to figure out how best to display this. Excellent. Okay. So again, we're using this formula, but replacing u and v with b and c. So we have cosine of b, cosine of c, plus sine of b, sine of c. Remember, fully replace the trig functions with what they are. So, cosine of b, that's 12 over 13. Cosine of C, that's negative 15 over 17. Sine of B, that's negative 5 over 13. And then sine of C is 8 over 17. Multiplying. 12 times negative 15, that should be negative 180, yes. 13 times 17, that's 221. Plus 8 times negative 5, that's negative 40. 13 times 17 is still 221. Negative 180 and negative 40, that is negative 220 over 221. Number 20, tangent of A plus B. So again, we're using the sum formula. Replace u and v with a and b. So we have tangent of A plus tangent of B over 1 minus tangent A tangent B. And just to really reemphasize, this step here is not a suggestion, it's not optional, this is one of the points. So if you jump right into it, you're going to lose a point. It's always good to set up a formula first before you dive right in and start doing the calculations. All right. Tangent of A is 3/4 plus tangent of B is negative 5/12 over 1 minus, and then it's those same two fractions multiplied together, 3/4 times negative 5/12. From here, it's just a lot of tedious simplifying. So I'm going to hold off on getting common denominator here. There's an algebra trick I'm about to use. I've used it plenty of times in class. If you prefer, if you are team keep, change, flip all the time, you can do that. You would get common denominator up here, combine the fractions. Same thing on the bottom, get a fraction over a fraction, and then you can keep, change, flip. But I like the algebra trick. I think it's quicker. All right, so we have 1 and then minus 3 times 5, that's 15, over 4 times 12, that's 48, and that's a negative 15. So I am going to go ahead and acknowledge that it becomes a plus. I did hold off on doing that. I was going to go ahead and make it a plus originally, but I waited just because sometimes it's still a minor mistake we make that completely throws off the rest of the problem. So I do recommend being careful when you do that. Okay, so to get rid of the fractions, I'm going to multiply top and bottom by the biggest of the denominators because 48 will obviously get rid of this fraction. It will also get rid of both of these because 4 and 12 both go into 48. So I will multiply top and bottom by 48 over 48 and take care to fully distribute through both of these. Okay, you can do this by hand or you can put it in the calculator, but I'm just going to tell you how that turns out. 48 times 3/4 is 36. 48 times negative 5/12 is negative 20. Again, you can type that into your calculator one at a time. 48 times 1 is 48, and then the 48 will cancel out with this denominator, so that positive 15 is all that's left. From here, I just need to get my final answer. 36 minus 20, that's 16. 48 and 15, that is 63. So 16 over 63 is my final answer. Number 21. Sine of 2c. Now we are getting into the double angle formulas. It's this one here. Again, replace the u with c. That is 2 sine of c cosine of c. And then we replace sine of c and cosine of c with what they are equal to. That's at the table in the top. So sine of c is 8 over 17. Cosine of c is negative 15 over 17. And we just multiply. You can put all this in your calculator and multiply it out if you want. Just make sure your answer is a fraction. I like to multiply on paper and do the fractions first. 8 times negative 15 is negative 120. 17 times itself is 289. And then remember, this is like 2 over 1, so I just really multiply the top. 2 times negative 120 is negative 240 over 289. I'm a big fan of those. Those are really quick. Number 22. Cosine of 1/2 a, and I'm going to rewrite this in a slightly different way. I think it'll make more sense when you're looking at it. Cosine of a over 2. So hopefully this is clearly the half angle formula. This one here, replace the u with an a. I'm going to need a little extra space on this problem, just an FYI, so I am going to kind of cut out some space here since I didn't need it for the previous problem. Okay, we have plus or minus the square root of 1 plus cosine of a over 2 plus or minus the square root of 1 plus, now we know cosine of a is negative 4/5. All over 2. Again, that information's in the chart at the top, in the box at the top. Now from here, I like to use the algebra trick to get rid of the fraction, and I'm talking about the little fraction inside of the big fraction, not the whole fraction. So, get rid of that denominator of 5, so I'll multiply top and bottom by 5. Make sure on the top you're fully distributing through, since you're multiplying an expression by the number. From here, we have plus or minus square root. 5 times 1 is 5. And then 5 times this denominator 5, those will cancel, so that just becomes a negative 4. 5 times 2 is 10. Plus or minus square root, that becomes 1 over 10. Now I'm going to split these up because 1 is a perfect square. Plus or minus, we have the square root of 1 over the square root of 10. Plus or minus, that's just a 1 on top now, over the square root of 10. Square root of 1 is 1. Reminder, you can have a radical on the bottom. Let's get rid of that. Multiply top and bottom just by that rad 10. So that becomes plus or minus rad 10 over rad 10 times itself is just 10. And when you think you're done, you're not, because reminder, these problems, when you have the plus or minus, this is a question you have to answer, either at the beginning or the end of the problem. You have to determine, is this a positive answer or a negative answer? It depends on the quadrant. So let's have that discussion. So this is all going back to A. And unfortunately, we don't know what A is. A is an angle. And we know A is an angle in quadrant, look at my notes at the top here, quadrant 3. So A is in quadrant 3. So if A is in quadrant 3, we need to figure out what A over 2, which quadrant that is in. That will tell us if cosine is positive or negative. So, reminder, I know this because it told me up here, A is between 180 and 270. Now, fortunately for us, if we look at our unit circle, and we look at quadrant 3, you can pick any angle in here. And remember, it has to be between 180 and 270, so it can't include those. So pick any of these three. Let's do 240, it's even. Half of 240 is 120, that's up here in quadrant 2. So, if I take half of A, whatever A happens to be, I'm going to end up in the second quadrant. If you believe that, oh, well, what if you chose a different angle? It might end up differently. Let me go further down this rabbit hole with you. Now, it has to be between 180 and 270, so it can't be either of these. So, let's look at those, like that boundary, if you will. Half of 180 is 90, so it can't be 90, so it has to be bigger than 90. and then the end of that boundary was 270. Half of 270 is 135. So if we're going to get really specific, a over 2 is somewhere between 135 and 90, because that's half of the boundary of that, of a. So a over 2 is somewhere in here. It is still in quadrant 2, regardless of which angle you chose. So a over 2 is in quadrant 2. So cosine is, in quadrant 2, cosine is a negative number. You can either use that acronym, all students take calculus, all students, S. So in quadrant 2, S is positive, sine is positive, cosine is negative. Or you can just look at the unit circle and look at cosine on any of those angles. It's negative in quadrant 2. So this is a negative rad 10 over 10. Final answer. That seems like a lot of tedious work, I am sure, but that is our absolute final answer. Number 23. Tangent of 1/2 c. So we can write that as tangent of c over 2 if you prefer that format. Now I'm sure you're thinking, oh goodness, I have to do that again. Reminder, tangent of the half angles doesn't have that pesky plus or minus, so we don't have to worry about that here. You have options. I've always said this before, whenever you have options with either of the cosine 2u or the half angle for tangent, that's where you have multiple formulas to choose from. It is my experience that the top angles in those, the top formulas in those lists are the easiest to work with. So I'm going to use that one for my problem. Again, replace the u with c. So we have 1 minus cosine of c over sine of c. Don't veer off the formula. It's really easy to get distracted. Just follow it symbol by symbol, and you'll be just fine. Okay. Now we can replace the sine and the cosine. 1 minus, looking at my notes at the top, cosine of c is negative 15 over 17. Again, I'll go ahead and acknowledge that this becomes a plus. And then sine of c is 8 over 17. Now you could easily keep change flip on this problem. That would be an easy problem to do this with. But I'm still going to stick with my preferred method with the algebra trick. These fractions both have a denominator of 17, so multiplying top and bottom by 17 will easily get rid of those. Be sure to fully distribute on the top since there's multiple things there. We've got a full expression. All right. On the top, distributing, we get 17. This is now a plus. The 17 cancels out with the denominator, so we just have 15 there. And then on the bottom, the 17 also cancels out with that 17, giving us just 8. So then we end up with 17 plus 15, which is 32 over 8, and that should look familiar. It is 4. So that one actually turned out pretty nice. 3 more on this page. Number 24, cosine of 2a, that is a double angle. This one here. Again, you have options. I recommend the top one. So I'm going to use cosine squared a minus sine squared a. Fully replace the cosine and the sine. Cosine of a was negative 4/5. And then since the original was squared, I'm going to square that as well. Minus the sine value is negative 3/5. Also square that. Make sure you're careful. Don't change this to a plus yet, because remember when you square this negative, it actually will become a positive. So just make sure you're careful and don't make that error. All right, negative 4/5 squared, that is positive 16/25, minus negative 3/5 squared, that is positive 9/25. 16 minus 9 is 7, so 7/25 is our answer. Number 25, tangent 2b, that is another double angle. This one here. So again, replace the u with the b. 2 tangent of b over 1 minus tangent squared b. Replace the tangent of b with what it's equal to. Tangent of b, looking up at my notes, negative 5 over 12 over 1 minus negative 5 over 12, and then that was squared before, so this is going to be squared. Again, reminder, square this before you consider the signs. On the top, this is going to reduce a little bit. I'm going to go ahead and do some canceling here if that's all right with you. 2 and 12, the 2 goes to a 1 and the 12 goes to a 6. Okay. So that is going to end up giving us a negative 5 over 6. If you didn't do that and just multiplied through, you still would have ended up with the correct answer. So it really didn't matter if you reduced there or not. 1 minus negative 5 over 12 squared. That is positive 25 over 144. Square the top and the bottom. Now I need to get rid of the fractions. Again, I like to multiply top and bottom by something that would make this work for me. So I'm going to multiply the top and bottom by 144. That's the bigger denominator. And believe it or not, you can divide 144 by 6. And then don't forget to fully distribute on the bottom. Now I'm not going to show all of the work, but you can type this into your calculator. Negative 5 over 6 times 144. You end up with negative 120. And then the bottom, 144 times 1 is 144. Minus 144's cancel, we're left with that 25. Negative 120 on top. 144 minus 25 is negative 119. Or sorry, positive 119. There's our answer. One more on this page, number 26. Sine of 1/2 a. So again, this is a half angle formula. That's the same as sine of a over 2. So we have plus or minus the square root of 1 minus cosine of a over 2. So yes, we're going to have to work with that plus or minus again. But the good news is we already know from number 22 here that a over 2 is in the second quadrant. So we just have to think about that at the end of the problem, what it means for sine. But that will only take a moment. All right. We have plus or minus square root of 1 minus, and then cosine of a was negative 4/5. Since we're not squaring here, I can go ahead and change this to a plus. So we have plus or minus the square root of 1 plus 4/5 over 2. And then times, I want to get rid of that fraction on the top, the 4/5. So we're going to multiply top and bottom by 5 to accomplish that. Fully distribute on the top. That will give me plus or minus the square root. 5 times 1 is 5. Plus the 5 will cancel out the denominator, so we're left with the 4. Over 2 times 5 is 10. We have a little bit of simplifying to do. Go ahead and separate top and bottom. Or actually, yeah, I'll do this in one step. Plus or minus. On top, I'll get the square root of 9. And on bottom, I'll get the square root of 10. Square root of 9 is 3, so plus or minus 3 over square root of 10. Square root on the bottom is not allowed, so we need to get rid of that. multiply top and bottom by that square root to get rid of it. So we have plus or minus 3 square root of 10 over rad 10 times itself is 10. Last but not least, we have to ask ourselves, is it a positive or a negative? So reminder, we're looking at a over 2. In the second quadrant, that's where a over 2 is. We figured that out earlier. In the second quadrant, sign is positive because remember, all students take calculus, and S, that's the second quadrant. So I can make a note here. Sign is positive. So for my final answer, it is a positive 3 rad 3 over 10. Of course, you don't have to write the plus itself because that's not necessary when your answer is positive, but this is just me emphasizing this is a positive answer. Okay, next page. Using any of your new identities and the special angles, find the exact value of each. So for each of these, I'm going to show you the different ways you can go about doing them, just to show you that you have options. But there's always a fastest way, and it just depends on the problem. So I'm going to go ahead and give you a couple tips as far as like when you want to use each formula. First off, easy to use formulas. Sine and cosine for the sum and difference, these are easy. They're typically fractions, and then you multiply the fractions, and then you add them, and you get your answer. Very little work. Tangent, avoid if at all possible, because tangent with sum and difference, if you remember those when we did those notes, they're tough. They're quite a bit of algebra. They're easy to make mistakes, so avoid these if you can. The double angle formulas, these are all nice to use. I don't have a problem with any of them, so if you can use these, use them. Half angle formulas, I really like these for tangent because you don't have to worry about that plus or minus, or you don't have a square root, so tangent is really nice here. Sine and cosine, they are quite a bit of work. I would still prefer these two over the sum or difference of tangent any day, personally. But these are still quite a bit of work, so if you could avoid these and try something else, I would consider doing that as well. With that being said, looking at all 6 problems together, if you see decimals, 29 and 30, which 30 is a decimal, we'll get to that later. If you see a decimal, you only have one option of what type of formula you can use. And that is the double angle formula, or the half angle formula. Sorry, I get myself confused. So I'm going to go ahead and write that down now. These are halves. So if you see a decimal angle, it has to be the half angle formula. The reason why that is because you can't use the sum or difference because, reminder, when we're doing these formulas, we are plugging in special angles. That means they're angles that are on the unit circle. None of these that are listed are decimals. They're all whole numbers. So clearly you can't get this decimal from 2 whole numbers. Not possible. So when you're adding or subtracting. So for 29 and 30, these are out. That leaves double or half angle. Well, if I take a number times 2 to get to a decimal, that number times 2 is going to also be a decimal, if you think about it. So like for 22.5, half of 22.5 is 11.25, so that's what u would be. That doesn't work. Whereas I could take a whole number and divide it by 2 to get a decimal. So that's why your only option for those are the half angle formulas. So if you can remember that, that's going to make figuring out what to do first really easy. A really easy decision. The other 4, 27, 28, 31, and 32, those are all whole numbers. So those are the ones where you have options. And again, it just depends on which options you're allowed to use are going to make it easy or difficult to solve. You will still arrive at the same answer, but again, the work is going to vary. So, tangent of 15. So with this, we can talk through your options. we can start with the sum or difference formulas. And I'm actually going to do this on a Post-it note just because I am going to struggle to have enough space. So we can talk about the sum or difference formulas. Option 1, we could do sum or difference. So two numbers, when added, that give me 15, they're going to be too small to get 15. If they're small enough that add to 15, they're too small to be on the unit circle, because 15 isn't even on the unit circle. So this has to be a subtraction problem. So this is where we work with the 30, 45, or 60. Those are good starting places. The good news for us, we know that 45 minus 30 equals 15. So our first option, we could do tangent of 45 minus 30. We could do that to get our answer. Let's consider option 2, the double angle formula. So if we did tangent of 2u for that, we'd have to have a number times 2 to get to 15. Well, I've already told you that number is too small. That would be tangent of 2 times half of 15 is 7.5. 7.5 is clearly not on the unit circle, so that's not going to work. So our last option is the half angle formula, which is tangent of u over 2. So we need a number divided by 2 that gives us 15, and that number is 30. You got to make sure it's a special angle. 30 is on the unit circle. So these are the two ways you can solve number 27. I will tell you, there is a clear difference in the work. I actually did the work completely for both problems, and I can't find that sheet right now. But I will tell you, if you did both of these, you would agree with me, the half angle formula is much quicker. So the choice is ultimately yours, but that's my recommendation. Do the half angle formula on this one. If you want to do the difference formula and then compare it, you're more than welcome to. So I'm going to use option 3 here. So I'm using tangent of 30 over 2. As long as whatever is in parentheses gets you 15 and the angle for you is on the unit circle, you can use it. So, and I've already said earlier, I really like the half angles for tangent. They're very straightforward. Okay. So that is equal to 1 minus cosine of 30 over sine of 30. One minus unit circle. Cosine at 30, that's the x value, is rad 3 over 2. Over sine of 30 is 1/2. If you wanted to keep, change, flip, this would be a good problem for it. The denominators would cancel quickly. But I am stuck in my own ways. I really like to just eliminate those denominators. They are both a 2, so I'm going to multiply top and bottom by 2. Fully distribute on the top. That's going to leave me with 2 minus rad 3 over 2 times 1/2 is just 1. They're reciprocals. So I have 2 minus rad 3 as my answer. Now, reminder, what is absolutely convenient about these problems on this page, they're all plugging in numbers, so you can very easily verify your answer with your calculator. I will demonstrate now. So first type in the problem, tangent of 15. Let me turn my brightness down. That's better. And then your answer. 2 minus the square root of 3. As long as they match, like these two do, you are good. Your answer is correct. And you can feel confident that you did what you were supposed to. There's the sheet. I did find the sheet with both problems worked out, so I do want to show you. So again, this is showing the comparison between doing it with the difference formula versus what I just did. If you did it with the difference formula, this is all the work you would have to do. Whereas the half angle formula, which I literally just showed you this same work, was so much quicker. So again, there are options, but there's typically a better one. All right, number 28. Sine of 285. So let's talk about options. Again, if it's a whole number, you can use a sum or difference. And then reminder, I said this earlier, sum or differences are not fun when it's tangent. Sine and cosine are nice. So I would probably do a sum or difference if it were me choosing to do it like on my own. So you have to test 30, 45, and 60. Remember, 45 is kind of the golden child here. We like 45. So see if you can use 45 to get to 285. 285 minus 45 is 240. And 240 is on the unit circle. So you can rewrite sine of 285 as sine of 45 plus 240. And you can use that. So that's one option. Let's see if you could do a double angle formula. So that would be sine of 2 times what number? So let's figure out what half of 285 is. Half of 285, I can tell you, is a decimal, so that's not going to work. 142.5. That is not an option. So the other option has to be the half angle formula, if there is one. So that would be sine of a number over 2. So we're obviously going to have to double 285 to get that number, which is obviously going to be a big number, 570. This is something you can do, but you have to be very careful because 570 is not viewable on the unit circle. You're going to have to figure out where it lands. So I wouldn't recommend that one either. So we're going to do the sum or difference formulas. And a reminder, with sine and cosine, sum and difference is actually very easy. Very simple math. So we are doing sine of 45 plus 240. So we have sine of 45 cosine of 240 plus cosine of 45 sine of 240. So I just copied down the formula above, replacing u and v with 45 and 240. From here, unit circle to get these numbers. So again, we like 45 because 45, both sine and cosine are rad 2 over 2. So I'll start with that. We'll go and fill those in. Rad 2 over 2 for sine and the cosine. And then let's fill in the 240. 240 is in the third quadrant. Cosine is negative a half, and sine is negative rad 3 over 2. From here, we just multiply the fractions and then add what we get from there. Rad 2 times negative 1 is negative rad 2. Don't forget to multiply on bottom. 2 times 2 is 4. Plus Rad 2 times negative rad 3 is negative rad 6. 2 times 2 is 4. Remember, you can't actually add these. They are different radicals. So the only thing left to do is write them together as one fraction. Negative rad 2 minus rad 6 over 4. On top of that, if you had your answer exactly like mine, but these are flipped, that's fine. Once again, do not forget to go ahead and check your answer in the calculator. It doesn't hurt. Plus, this will help you catch your mistakes. Reminder, the fraction shortcut is alpha x. Yep, they match. We're good. 2 more. 29 and 30, I've already figured out. They are half-angle formulas. That's how you handle decimals. So that kind of takes some of the guesswork out of it. Cosine here. So, cosine of what number over 2? What number divided by 2 is 22.5? 22.5 times 2 is 45. So that is what we're going to use. Half angle formula, u is 45. So we have plus or minus square root 1 plus cosine of 45 over 2. And these problems aren't bad. We've already done plenty of them today. So better practicing. Plus or minus square root 1 plus, you should already know what cosine of 45 is. I just talked about it. It's rad 2 over 2, all over 2. We want to get rid of the fraction up here. So we multiply by the denominator, which is 2. Multiply the top and the bottom. Distribute on the top. We get plus or minus square root 2 times 1 is 2. Plus, the 2's cancel here, so we just have rad 2 on the top. 2 times 2 is 4 on the bottom. I'm going to separate this here for a moment. Plus or minus square root of 2 plus rad 2 on top over rad 4 on bottom. Notice the perfect square, so we have plus or minus square root 2 plus rad 2 all over square root of 4 is 2. No radical on the bottom anymore. And then do not forget, your final answer should not have that plus or minus. The plus or minus is a question you have to answer. And the question is it plus? Is it a positive or a negative? So we go back to the original, the 22.5. 22.5 is in the first quadrant. And this one's easy. Everything is positive, so cosine specifically is positive. So our final answer is just the positive. Square root of 2 plus square root of 2 all over 2. And then if you check with the calculator will be another hint about that sign, because obviously the calculator will have the positive or the negative answer. So if you forget about it, that's how you'll know as well. Calculator will come in and save the day on this problem. Cosine of 22.5. And then alpha x for my fraction. All right, square root of 2 plus another square root, 2 over 2. And they come out exactly the same. 3 more. We've already talked about that this is a half angle problem again. Now you should recognize this notation. This is degrees, minutes, seconds. And you can use your calculator to get it back into decimal form. So we've got 1/12. And then, in case you forgot, it's the apps button, but you want the angle menu. So second apps, degrees, 30, second apps, go down 1 to get the minutes button. Let me see if this will help it focus. It's getting there. There we go. Hopefully you were able to catch all that. And then you hit equals, and it turns it into a decimal. 112.5. So this problem is actually tangent of 112.5. Since it's a decimal, this has to be a half angles formula. That's how we can use a whole number in our formula. So tangent of something over 2. What number divided by 2 is 112.5? That number is 225. 112.5 times 2 is 225, which is on the unit circle. So we can use that. And then reminder, the half angle formula for tangent is actually really nice to use. And it doesn't have that plus or minus sign that you have to worry about. And you have options. I like the top one. Again, go with the top one typically. It's usually the better one. 1 minus cosine of u is the 225. Over sine of 225. 1 minus unit circle. (225). Cosine is negative rad 2 over 2. Sine is also negative rad 2 over 2. Since we're not squaring here, we can acknowledge that this is a plus. And then on top of that, I want to get rid of the fractions. They are both 2's for the denominator, so multiply top and bottom by 2. And then fully distribute on the top specifically. That gives me 2 plus rad 2 over negative rad 2. Now we have another problem we have to address, and that's the radical on the bottom of the fraction. Not ideal. So we need to get rid of it. Now this time you can either multiply by a positive or a negative radical too, since it's not a full expression. I'm going to keep the negative on the bottom to make this easier, so I'm just going to do a positive rad 2 over 2. Don't forget to distribute on the top. Rad 2 times 2, that's 2 rad 2. Plus rad 2 times rad 2 is just 2. On the bottom, negative rad 2 times rad 2 is negative 2. Now let's make this look a little nicer. I'm going to split this up into two fractions. 2 rad 2 over negative 2 plus 2 over negative 2. First fraction, the 2's cancel out. So this becomes a negative rad 2. And then this becomes a negative 1. Now technically we write the radical second. We want the whole numbers first. So if it were me giving the answer to the problem, I would do that one. But these are both accurate, so it doesn't matter which way you write it. Just make sure the signs are correct. All right, check. Tangent of 112.5. And then negative 1 minus the square root of 2. And then just to show you the opposite one is the same. Negative rad 2 minus 1. Yep. So again, you have options. 2 more. Sine of 165. So this is a whole number problem. So again, you have options on what you want to do. You could work with sum or difference formula. You can for sure find two angles, either added or subtracted, that will give you 165. And then the half angle or the double angle formula won't work because you will need to take half of that 165 to put a number in here. 165 is odd. That's not going to work. So half angle formula will be your other option. That's going to give me a pretty large number. So it's still doable. I actually did that one on my own like that. But on these, I really like to keep it simple and do sum and difference. The math on these it's really easy. So I'm going to do these on the last two problems. So we need to find u and v. And again, it can be adding or subtracting. With how we taught it in class, we typically do adding pretty much always, but you can do subtracting if you find it easier. 30, 45, and 60 are the angles to test, 45 being the golden one. If you can, use it. 165 minus 45 is 120, which is on the unit circle. So I can break sine of 165 into sine of 45 plus 120. So that's the formula I'm going to use. So I have sine of 45 cosine of 120 plus cosine of 45 sine of 120. Again, the reason we like that is because we already know sine and cosine. They are both rad 2 over 2. Again, you can get that from the unit circle. And then we look at 120 to get sine and cosine for those. 120, cosine is -1/2, sine is rad 3 over 2. From here, just multiplying fractions. Negative rad 2 over 4 plus rad 6 over 4. And then remember, we can't actually add these, so we just combine them into a single fraction. Negative rad 2 plus rad 6 over 4. Check with the calculator. So that was sine of 165. And then alpha x to get my fraction. Negative rad 2 plus rad 6 over 4. Now, if you do it with the half angle, like I mentioned earlier, I'll just show you real quick my work for it. This is how the problem works out. So if you do the half angle, you find double 165, that's 330. That is on the unit circle. The work is kind of minimal, but you'll notice that you do get, show them side by side. Actually, do it like this. You do get a very different answer. It appears different. Now, when you put this in the calculator, they are exactly the same, but I just wanted to warn you about that. If you do it that way and get it, it's going to look different from mine. Also, the downside of the half angle formula is you have to think about that plus or minus. So doing the sum saves you from having to do that. All right, last problem. Cosine of 255. Once again, I'm going to use the sum or difference formula. Very easy on these. And cosine and sine, those are so easy to do with those. It's the tangent that sucks. Okay, we test 30, 45, 60. 45 is ideal if we can use it. 255 minus 45 is 210, which is on the unit circle. So I can use cosine of 255 is equal to cosine of 45 plus 210. Let me grab that formula. So we have cosine of 45 times cosine of 210 minus, be careful here, sine of 45 times sine of 210. All right, we already know the 45. That's why we use it. Rad 2 over 2. Unit circle, look at 210 for sine and cosine. 210. Cosine is negative rad 3 over 2. Sine is negative 1/2. Multiply the fractions and then combine them. Multiplying, we get negative rad 6 over 4 minus negative rad 2 over 4. Clearly this is going to become a plus. Negative rad 6 plus rad 2 over 4 is our final answer. And last but not least, check with the calculator. Cosine of 255, alpha x, and then second, let me put in my negative first. Okay, now my square root, there we go, 6 plus the square root of 2. No, I somehow hit alpha, my apologies. There we go, over 4. And they came out the same, again, like they're supposed to. So reminder, on this page, any of the whole number problems, you can use sum or difference. As long as they're sine and cosine, that would be my recommendation. If it's tangent, I'd find something else to use. Tangent is not pretty there. All right, that is all for this video. I hope that this was helpful. I hope this gave you some things to think about, some things to work on, that kind of thing. If you have any additional questions, feel free to reach out to me via email or come see me in person before you take your test. Otherwise, I will see you guys later. Bye.